Welcome everyone to episode 4 of Math 104 Final Exam Review. So we're working on chapter 6 today. We're going to start off by finding the domain of a function. Recall that the domain is all the values that you can plug in and get a real answer out. So what we want to avoid here is division by 0. So we need to see what's going to make the denominator 0. Don't worry about the numerator. The numerator is irrelevant. Only looking at the denominator. So we're going to factor this thing. Into x minus 5, x minus 2. Use the zero factor property, set them both equal to 0. We get x equals 5 and x equals 2. So these are the values that if we plug these in, we're going to get division by 0. So these are not in the domain. So that's going to make our domain in interval form. Negative infinity to 2, 2 to 5, and 5 to infinity. So this is all real numbers except 2 and 5. And there's set builder. So same deal for number 3. We got a perfect square trinomial, factors into x minus 9 squared. And we get x equals 9. So 9 is excluded from the domain. So since there's only one number, we'll only need 2 parts to the interval notation. All real numbers except 9. Now with number 4, we are going to simplify these. So for this entire section, the technique will be factor and cancel. So here we can factor out 6x and get 2x plus 1. And the denominator, we can factor out a 12. And we get 2x plus 1. So now we have matching binomials. Those will cancel. So those go away. Now we just need to reduce the fraction. 6 over 12 reduces to 1/2. So that reduces to x over 2. Next up, number 5. We've got some factoring to do here. Special forms. Got difference of squares on top. So that factors into 5m plus n, 5m minus n. And on the bottom, we have a perfect square trinomial. So that will factor into 5m minus n squared. So now one of these 5m minus n's is going to cancel. All right, we have 2 of them on the bottom, so we'll get rid of one there, we'll get rid of that one. And what we have left is 5m plus n over 5m minus n. Same deal for number 6, factor and cancel. Difference of squares on the bottom. So this gives us r minus 2 over 2 plus r times 2 minus r. So now we've got nearly matching binomials, but they're in a different order. So we're going to use our flip trick. I'm going to flip this binomial to r minus 2, and that'll make it negative. All right, flip that one. And I'm going to cancel those, and that gives us 1 over, we're going to say negative out front. negative of 1 over r plus 2. So we're going to factor and cancel again. We can do some canceling before we do any factoring. All right, we got y on the bottom, y to the third on top. One of those y's is going to disappear. And then 15 over 5 reduces to 3 over 1. All right, so we're down to 1 here and 3y squared there. All right, so now we're going to do some factoring. It's often very helpful to rewrite these things because they get a little sloppy with all the cancellations. Difference of squares here, that's going to factor into 2y plus 3, 2y minus 3. Now I've got a matching 2y plus 3. Notice there are clues built right into these problems. When we start factoring, you should get some cancellation. So we got 2 of them up top. One of those is going to go away, and that one goes away. So we're left with 3y squared times 2y plus 3. Over 2y minus 3. Number 8. Nothing we could cancel right off the bat, so let's factor this thing. Difference of squares, w plus 4, w minus 4, over w. And now we're going to do the flip trick here so that I get a match. So I'm going to change this to w minus 4, and it becomes negative. Now we got matching binomials. Those go away. All that's left on top is 3 times w plus 4 over, got that negative sign, don't forget that, over w. Number 9, now we're moving to division. I'm going to go ahead and do the first step. And change to multiplication. So we're taking that second fraction and flipping it over, changing the division to multiplication. So this would be the result of step 1. Now we can factor here, the difference of squares, x plus 2, x minus 2. Now we've got 2 cancellations we can make. X minus 2s, those are gone. X plus 2s, those are gone. The only thing left is x minus 4. Number 10. bunch of stuff to factor here. Here we've got two numbers are multiplied to get -6, add to get -1. That's going to be -3, +2. So that factors into z minus 3, z plus 2. Well, here we can factor out a z. Now that matches here, so that's good. And here we got two numbers multiplied to get -15, add to get 2. That is going to be z plus 5, z minus 3. All right, now we factor, now it's time to cancel. Easy going. What do we have left here? We have z times z plus 2 on top over z plus 5. Number 11. All right, factor and cancel. Here we can factor out a 2. And 8 plus x. Here we got difference of squares, that is x plus 8, x minus 8. Now these are in different order, but it's addition, so it doesn't matter, so those still cancel. Now we've got x plus 8 and 8 minus x. We're going to need to do the flip trick here. Get negative of x minus 8. Now the x minus 8's cancel, and we're left with negative 2 over x plus 8. Number 12. Got a division problem here. So I'm going to do the same thing as I did last time. Our first step that right here is going to be converting to multiplication. I'm going to flip that second fraction over. N plus m on top, or m plus n, doesn't matter. Let's do some factoring now. Okay, difference of cubes. We have the negative version, so we'll start off with m minus n. We got m squared plus mn plus n squared. Difference of squares. Go ahead and switch that back around. It's supposed to be m plus n. And then here, there, well, that does not factor. That's going to stay as m squared plus nm plus n squared. All right, now we've got a match. You know, I wrote those in different order again. Multiplication is commutative, that doesn't matter. So those are equivalent, so those cancel. And now we've got m plus n, so that's going to cancel as well. And n minus n, that also cancels, so everything cancels. So we're left with 0? No. When we cancel, it turns into 1. We're moving on to section 6.2. Now we are going to list some denominators. And we're going to find the LCD of that group of denominators. So let's look at the coefficients first. Only these two have a coefficient, and it is 9, so that's going to be the coefficient of the LCM. And now we can look at the individual variables, just one. So our largest exponent is 2, so that is r squared. And then we have this binomial, 3r plus 1. 9r squared times 3r plus 1. $15. Right, we got 6x squared plus 13x minus 5. And we got 9x squared plus 9x minus 4. Now, in order to find the LCD for this group, we're going to need to factor both of these. So first one, actually both of these, we'll use the AC method. So for the first one, AC is negative 30, 6 times negative 5. And we need two numbers that multiply to get negative 30, add to get 13. So that'll be 15 and negative 2. So that means we'll split this thing up into 6x squared plus 15x minus 2x minus 5. And now we can factor by grouping. What am I doing? Oh, factoring out 3. All right, we'll factor out 3x from here, get 2x plus 5. And here we'll factor out a negative 1. And because this is the matching binomial, 2x plus 5. So that one factors into 2x plus 5 times 3x minus 1. Now we'll do the next one. Here we have an AC of negative 36. And we need two numbers that multiply to get negative 36, add to get 9. So that's going to be 12 and negative 3. And again, we can factor out a 3x from the first two. That gives us 3x plus 4. Factor out a negative 1 here, and we get 3x plus 4. So we got 3x plus 4 times 3x minus 1. Now the LCD then will be every unique binomial. All right, we got matching 3x minus 1s. Doesn't matter that they match. They're both to the first power, so we're just going to include one of those. So we have 3x minus 1. Then we have 3x plus 4. And 2x plus 5. And there is your LCD. Number 16. All right, we've got three denominators here. We're going to find the LCD of these. We need to factor. We've got 3 times x minus 4. And this one factors into x minus 4x plus 2. And perfect square trinomial is x minus 4 squared. All right, first thing, see if we have any coefficients. And we got a 3 out front here, so we're going to have a 3 out front in our least common denominator. Now let's look for unique binomials, x minus 4. We have 3 of them. The largest exponent is 2. So x minus 4 squared. Let's include the largest exponent and then x plus 2. That's all the unique binomials. So there's your LCD. All right, now we're going to start adding or subtracting. So we're on next to number 19. So we'll start by looking at these denominators. We're going to do the same thing we did before. Let's factor both of these. Right? For 5a plus 10, we get 5 times a plus 2. And here, we get 6 times a plus 2. All right, now we have to look at our two numbers here and find the least common multiple of 5 and 6. That's going to be 30. And we have just the one unique binomial. So our least common denominator is going to be 30 times a plus 2. So that means we need to transform both of these fractions to have this denominator. So I'm going to rewrite them with the factored form of the denominator. Now we already have the a plus 2, so we don't need to do anything with the binomial. We just need to match the 30. So I'll multiply this one by 6 over 6, and this one by 5 over 5. And that will give us 30 times a plus 2 in the denominator of both fractions. Add them together, we get 71 over 30 times a plus 2. Number 20. So we'll start by factoring the denominators. And we have, in this case, go ahead and use the AC method. 10 times negative 1 is negative 10. And when you two numbers are multiplied, you get negative 10, add to get negative 3. So that's going to be negative 5 and 2. We can rewrite this one as 10r squared minus 5rs plus 2rs minus s squared. Now I'll factor by grouping. Take out a 5r, that gives us 2r minus s. And here we can factor out an s, and we get 2r minus s. So that factors into 2r minus s times 5r plus s. And this one factors into 2r minus s times r plus s. I just did a little guess and check on that one. No need to do the whole method of like that. Okay, so now our LCD will be all the unique binomials. 2r minus s, r plus s, and 5r plus s. So now we need to transform these fractions so that they have a denominator just like this. So let's look at what's missing. Right, this one already has the 2r plus s, already has the 5r plus s, it's missing r plus s. So we're going to multiply this fraction by r plus s over r plus s. And then this fraction then write the denominator using the factored form. That way we can see what we're missing. And it looks like we have these two, and we're missing 5r plus s. So multiply this one by 5r plus s over 5r plus s. Now, since we're multiplying by binomials, we're going to distribute into the binomial. All right, I'm just going to write LCD for this. They both have those in the denominator. It's okay to do this. Just make sure the final answer includes the LCD as written. Okay, so over here we're going to distribute 2r in here, so that's 10r squared plus 2rs. And then finally we can combine them together. Combine like terms up top. That's 13r squared plus 5rs over our LCD of 2r minus s, r plus s, 5r plus s. Next up, complex fractions, number 21. Now, before we can convert division to multiplication, we have to be simplified down to one fraction on the top, one fraction on the bottom. Clearly, we did not have that here, so we're going to need to do some things first. Now, in this case, we've got a very simple denominator. Both of the little fractions have denominators of t. So that makes the least common multiple of the denominator is just t. So we can get rid of those little fractions by multiplying by t over t. And then we'll take this t and distribute it and numerate it in the denominator. All right, now, Multiplying t by 3 over t, the t's cancel, leaving just 3. T times 2 is 2t. And on the bottom, the t's will cancel here. So we get 4 minus 7t. And that cannot be simplified, so we're done. Didn't even need to convert to multiplication or anything like that. So that's the nice thing about method 2, finding that least common denominator for the little fractions, multiply it out, and all those little fractions disappear. Next up, 22. Now this one, we're starting with a simplified fraction on top and on the bottom, so we can go right to converting to multiplication. All right, flip that bottom fraction over. Don't distribute it. Just combine them. And notice we have two binomials here that are flipped from each other. So let's flip one of those. So we got n minus 3n's, they just match. We'll cancel those. And our answer is -2. Number 23. If we look at all the little fractions, we have p, q, and qp. So that makes the LCD p times q. So we're going to multiply this fraction by pq over pq. All right, now I'm going to take this pq and distribute it here. I take pq, put it on top here, the p's cancel, leaving just 3 times q. And then here, multiplying pq times 2 over q, the q's cancel, leaving just 2 times p. All right, so there's the numerator. Now the denominator, pq and qp cancel, leaving just 9q squared minus 4p squared. And now we can factor the bottom. Back to factor and cancel. Right, difference of squares, factor that. And now we got matching 3q minus 2p's. And final answer is 1 over 3q plus 2p. Next up, number 24. Now we got some negative exponents here. Now for problems with negative exponents, we're going to multiply both the top and the bottom by the largest exponent for each variable turned positive. All right, largest exponent for both x and y is a -2. We'll turn both of those positive and multiply by x squared, y squared over x squared, y squared. And that will eliminate all the negative exponents. Now we'll distribute in here. So we're going to multiply x squared times x to the -2 power. Those cancel each other out to equal 1. Remember, by the properties of exponents, we're going to add those exponents. And when we add them, we get x to the 0 power. Anything to the 0 power is 1. So that's pretty much gone. And now that becomes y squared in the first position there. And then for the second one, the y's cancel, leaving just x squared. So we get y squared minus x squared on top. On the bottom here, one of the x's will cancel and one of the x's will remain. So we get x, y squared. And here one of the y's cancel. So x squared y. Now we can do some factoring and canceling. Difference of squares, that turns into y plus x times y minus x. And on the bottom, we can factor out xy. And that gives us y minus x. Y minus x is canceled. And we're left with y plus x over xy. All right, last section where you're going to solve rational equations. 25. So let's look at these denominators and find a least common denominator. Let's factor first. Always factor completely all the denominators. And that factors into 2 times t plus 4. All right, now we look at the coefficients. We got 2 and 2, so that'll be the coefficient of the LCD. And then we have one unique binomial, t plus 4. So there's our LCD, 2 times t plus 4. All right, now we're going to get all these fractions to have that denominator. And this, let's just multiply by it. Now we can multiply by 2 times t plus 4. That will eliminate all 3 fractions at once. All right, first fraction, t plus 4, and on top and bottom, those are going to cancel, leaving just 2 times 1. Here the 2's cancel, leaving just t plus 4. And here that all cancels, leaving 3. And now I've got a regular linear equation to solve. All right, let's combine some like terms here. We get t plus 6 equals 3. Subtract 6 from each side and we get t equals -3. Now we have to check to make sure we don't get division by 0. So let's look at all the denominators. If I plug in -3 here, I get 1, so that's fine. If I plug it in here, I get 2. So it does not produce division by 0 in any of the denominators. So that is an actual solution. #26. So I'm going to start this one by factoring the denominator. All right, now we've got one unique binomial, n minus 1, or n plus 1, and the coefficients are 3 and 6. Least common multiple of 3 and 6 is 6. So that makes our LCD 6 times n plus 1. And now we'll get rid of all the fractions. All right, first fraction, the n plus 1's cancel, leaving just 6. So I'm going to multiply 6 by the numerator and get negative 30n. Second one, n plus 1's cancel. 6 divided by 3 is 2. 2 times m is 2m. And last one, everything cancels, leaving 56. Now we'll combine these, you get negative 28m equals 56. Divided by negative 28, and m equals negative 2. All right, let's make sure we don't get division by 0. If I plug in negative 2 here, I get negative 1, so that's fine. I get negative 3 here and negative 6 there. So no division by 0, and that is the real solution. 27. In this case, we have a proportion. So these are the nice kind of rational equation because all we need to do here is cross multiply. Numerator by denominator. All right, 10x plus 5 times 4x plus 3, and then set equal to 5x plus 5 times 8x plus 2. All right, now we can FOIL. So it gives us 40x squared plus 20x inside plus 30x and last plus 15 equals 40x squared outside plus 10x inside plus 40x and last plus 10. Now notice our x squared terms are equivalent, so we can subtract those from both sides and those go away. And we can combine like terms here. So we got 50x plus 15 equals 50x plus 10. Well, if we subtract 50x from both sides, those go away and we get 15. It's not equal 10. So that means there is no solution to 27. $28. So we'll start by factoring the denominator. Difference of squares. So apparently for our least common denominator, we've got two unique binomials across all the denominators, k plus 1, k minus 1. So we're going to multiply this by k plus 1, k minus 1. All right, first fraction. Here, the k minus 1s cancel, leaving 2 times k plus 1. Minus, here, both of these cancel, leaving the numerator. Now, keep in mind we're subtracting, so we have to put this thing in parentheses. We're subtracting the entire binomial. Now over here, the k plus 1s cancel, leaving k minus 1. So we get negative 1 times k minus 1. Now let's distribute. Combine like terms. And solve. We get k is negative 3. I think I did something wrong here. All right, let me make this over. It looks like I thought I was distributing a 4 here. That should be minus 1. So there was the mistake. Okay, so then we do plus 2, 1, gives us plus 1 here. Minus 1, 0. There we go. So k is 0. Okay, so now let's see if 0 gives us division by 0. Negative 1 here, negative 1 here, positive 1 here. So that is fine. And that is our solution. K equals 0. And that is why it's important to make sure you check all your solutions, because little mistakes like that pop up. All right, number 29. All right, so we'll start by factoring here, difference of squares. Now looking at the denominators, we have two unique binomials, r plus 2 and r minus 2. So let's multiply this entire equation by r plus 2 times r minus 2. All right, first fraction. The r minus 2's cancel, leaving r times r plus 2. Minus. Second fraction, both of these binomials cancel, leaving just 8, so minus 8. Equals, here the r minus 2's cancel, leaving the r plus 2's cancel, leaving negative 1 times r minus 2. Now distribute. Now it looks like we're going to have to get everything to the left. So I'm going to add r to both sides and subtract 2 from both sides. Now we get r squared plus 3r minus 10 equals 0. And that gives us a factorable trinomial. Now, if you get down to here and you see a trinomial here that is not factorable, then that's a good indication you made some mistake along the way. Because generally these problems are designed so that you can factor here, use the zero factor property and solve. And that's what we're going to do. Factor this into r plus 5, r minus 2, set them each equal to 0. So you get r equals -5 for that one. And r equals 2 for that one. All right, now let's make sure that both of these are going to work. Looks like -5 will not create any problems. But if I plug 2 in here, 2 minus 2 is 0, we get division by 0. So that is not a real solution. Only real solution is r equals -5. Last one, number 30. I'm going to start by factoring this. X plus 2, x plus 3. And now it looks like our least common multiple of the denominators is going to be x plus 2 times x plus 3. All right, now let's multiply this entire equation by that. We're going to multiply the first fraction here. X plus 2's cancel, leaving 5 times x plus 3. Second fraction, x plus 3's cancel, leaving 3 times x plus 2. And here they all cancel, leaving just x. Distributing. Combine-like terms. I'm going to subtract x from each side and 21 from each side. Minus x minus 21. It's 21 minus x. So that gives us 7x equals -21. And divide by 7 on each side, and we get x equals -3. Now let's test out -3. I plug in -3 here, -3 plus 3 is 0. So that's not a solution. So there is no solution to that one. Right, that wraps up episode 4. Stay tuned for the exciting conclusion of Math 104 final exam review.